In this video, we're going to apply L'Hopital's rule to find the limit of an indeterminate form produced by a quotient of the form infinity over infinity. It says evaluate the following limit using L'Hopital's rule, and it wants us to find the limit as x approaches infinity for 2x squared minus 13x plus 1 divided by 3e to the 19x plus 2x. If I plug in infinity right now, I'm going to get positive infinity on top. I plug infinity here, I will get positive infinity on the bottom, so I am indeterminate right now. Let's apply L'Hopital's rule, which says I can take the derivative of the numerator and the derivative of the denominator separately over and over again until I find my limit. So the limit as x approaches infinity, we're going to take the derivative of 2x squared minus 13x plus 1 over derivative of 3e to the 19x plus 2x. Derivative of the numerator is going to be 4. So we'll write limit x approaches infinity. That would be 4x minus 13 over derivative of e to the 19x is going to be 19. We're going to write that up here. Derivative of e to the 19x is equal to 19e to the 19x. So this is just chain rule application here. We do the derivative of e to the x, it's the same. That's why that's written there. Times the derivative of the inside, which would be 19. So we're going to end up multiplying that by 3. So 19 times 3, 57. So we have 57 e to the 19x plus derivative of 2x is 2. Let's plug infinity in, and again we get infinity on top and infinity on the bottom. So this is indeterminate again. I'm just going to write that this is ind. So then we're going to take the derivative again. So this is equal to the limit as x approaches infinity, d over dx of 4x minus 13 over derivative of 57e to the 19x plus 2. Derivative on top would be 4 over derivative in the bottom, bring the 19 to the front again, just like we did earlier. So 19 times 57 is 1083. E to the 19x, and the derivative of 2 is 0. But I forgot to write the limit in here. So let's evaluate that limit now, and we would end up with 4 over infinity, which is, anytime we have a small number divided by a very large number, we're approaching 0. So we can say that the limit as x approaches infinity, and I'm just going to say that this is f of x, save myself some writing. So limit as x approaches infinity of f of x, the original function, is equal to 0.